Welcome to this lecture series. In this series, we are seeing this aluminum composites, the two particularly on MXine. Okay, MXine material we are going to discuss. Okay, that MXine coming under 2D materials. Okay, 2D materials we should know because it's a single layer material is normally the graphene will be indicated as a single layer material. Next level is that 2D material, so it can increase the surface area, then surface functioning factors that again we can improve. So that is the 2D material. That is my concept on this 2D material. And a specific group of the people material is called metals are called MXine. We will explain one by one. 2D material or the materials there are only one atoms thickness. Okay, just 2D material is only one atom material thickness. With this atom we are going to form the layer. Okay, so it is just if you are taking a piece of paper, okay, so very thin, okay, you can barely see it. Okay, like that you can have you can take some onion peels, okay, that we are having very, very mild nice thickness, no, okay, that also we can take an example. Okay, so materials have special properties that make very interesting for scientists and engineers. Okay, they have a large surface area, that have a large, because thickness is more, no, so that functional area is more. So the large surface area of is available for the 2D material. There's a lot of space on the surface for reaction and interactions. This is like having a big sponge who can absorb a lot of water. Okay, it's a simple example for understanding, for better understanding. They're also having layer dependent properties, so that characteristics can change depending upon the how many layers you have. Okay, we are having, say if you have 2 or 3 layers, means the property is different. Single layer means single layer is somewhat difficult. So layer, based on the layers we can have this difference. A single layer will behave compared to this multi-layer. Okay, the multi-stacked layer. Then properties, key properties, optical band gap. Okay, this uh, refers to the how the material interact with the light. Okay, so that some materials can absorb certain colors of light while lifting others. Property is more important for the solar panels, so that this is having the optimal things, so that it can attract that the property is must for this disable property of this material. Then carrier mobility. So for the electric charges, okay, the electrons and the ions should be carried to this next portion. Okay, for the material, through the material, so that property higher mobility is better performance for the electronic devices for electrical conduction. In mechanical flexibility, so that it can bend without breaking. When you are applying load, you can bend without breaking, which is useful for making a flexible electrons like bendable screens. Then thermal conductivity. This is how well a material can conduct heat. Okay, good thermal conductors are important for keeping devices cool. So these are all the main properties. Already we have seen the optical band gap, then carrier mobility. Then carrier mobility means it can carry, carry this ions, okay, electrons to this through the material. Then mechanical flexibility, that is that without breaking it can flexible. Okay, use for many layers. Okay, many layers. It is also having a surface, the functional ratio, more surface functional ratio. The ratio between the surface to this thickness is very less, so very greater. Okay, so that it can make a proper wetting property too. So these are the main properties of this material. Okay, so with this advantage we are going to have this uh, have this material for many many applications, like capacitors, then electric batteries, then lubrications. Like that we can use this MXN for 2D materials for many applications. Okay, thank you.